right, topic 47, the second derivative test. And what's weird about this is it's a way to find extrema, local extremes, using the second derivative. Now, another second derivative, we talked about concavity and points of inflection, but there's a certain type of question where this test is used. So let's think about what it's saying. It says, suppose f double prime, so the second derivative is continuous on an open interval that contains c. If f prime of c equals 0 and the second derivative is positive, then what's going on? Well, let's just look at these two statements. If the first derivative is 0, okay, I could draw three different things maybe that the first derivative is 0. You could draw something like this, and right there, you could draw here. Now remember, you always have that case as well, where the derivative is 0. But in combination with that, if the first derivative is 0, so looking at those things, obviously I could have a straight line as well. I mean, the derivative would be 0 at any horizontal. But if the first derivative is 0 and the second derivative is positive, well, what did we learn yesterday? If the second derivative is positive, what do we know? We know that f is concave up from this statement right here. So if by looking at my pictures, that wipes out a lot, because if the first derivative is 0 and the second derivative is positive, that means f is concave up, then it would have to be this one. So what's going to be going on? Then f has a local min at x equals c. If the first derivative is 0 and we know that the second derivative is negative, well, then you know if the second derivative is negative, you know that f has to be concave down. So visualize concave down, then f would have a local maximum at x equals c. So the key parts about the second derivative test is there's two conditions. This has to be true as well. The first derivative has to be 0. So where the first derivative is undefined, the second derivative test is not going to help you. That doesn't mean you won't have a max or min there. The second derivative test is only used in very specific types of problems. Let's look at example 1. It says f has critical values at those 3 points, or those 3 x values. Given the second derivative is 4 minus 12x squared, determine any local extrema. Well, see, I can't do anything with the first derivative and tell where the first derivative is changing from positive to negative or negative to positive, because I don't have the first derivative. So this is a perfect example of the second derivative when you can use the second derivative test. So here's the deal. Are you clear? If it tells me I have critical values here and I have a polynomial, I know that the first derivative is 0 at all those points, because again, I have a polynomial, and so it's going to be defined everywhere, so the derivative can't be undefined. So the first part of this statement, this is true. At all these values, the first derivative is 0. So all I have to do is I need to evaluate the second derivative at all those points. It doesn't matter the order that you do it in. I just went in the same order as they were listed. If I plugged in -1 into the second derivative, well, what do I get? Well, I would get -8, which of course is less than 0. So f double prime, the second derivative is less than 0. I picture second derivative is negative, so that's concave down. Therefore, f has a max at x equals -1. Now, I can't find the y value, of course, because I don't even have f. So that's all I can really say. When I plug in 0 into the second derivative, I get 4. which of course is greater than 0. So f is going to be concave up. So f has a min at x equals 0. And I will say they like for you to put the either word local or relative, so I'm going to add that in there. And finally 1, well, that's going to give me the same thing as -1 did. So I will just add a little plus and minus right here, because f is going to have maxes at 1 and -1, and we'll have a minimum at 0. So this is the type of question that makes you use the second derivative test, because there's no way to do the first derivative test. Now, let's look at example 2. It says the first derivative is 0 at those 2 points. So they told you that. And they gave you the second derivative, determine any local extrema. So I have the first derivative being 0. What's the second derivative at -2? Well, the second derivative at -2, that'd be 0. And in the same way, the second derivative at +2 is also 0. So what can you say? Can I determine anything? No. Using the second derivative test, no conclusions can be made. So all I'm asking you to do, again, the second derivative test, if the first derivative is undefined, you can't use the second derivative test. It could still be a max or min, but you can't use the second derivative test. If you know that the first derivative is 0, and what you get for the second derivative is not positive or negative, if it's 0 or undefined, that means no conclusions can be made. So all I'm asking you to do on your homework, let me be very clear, it's just asking you to use the second derivative test. Okay, I'm not asking you to find the maxes and mins and thus use the first derivative or try to figure it out. You're only writing the answers that you can find using the second derivative test. So some answers, and I think I wrote it like this on the answer key, cannot be determined. Okay, you can't, the second derivative test doesn't lead you to any conclusions about extrema, one way or the other. So make sure that you're only doing that work and not doing more work than you need to. I'm just asking you to apply the second derivative test. And that's all. Easy lesson. See ya.